Hey Finxters, what's up? It's Chris, founder of Finxter.com, and in today's video you're going to learn about Python set.intersection method. So what happens? So how can we intersect two sets in Python given by this? So via the set notation. So say you have two sets S and T, and they intersect in at least one element. This is not a hard requirement, but I think it's the best example of showing set intersection. How can we create a new set that basically contains all the elements that are in both sets, like in sets S and T? And the answer is simple. So you call the set intersection on a given set. So it's a method, set intersection method, and you pass the other set which you want to intersect with this given set into the method, and then it returns a new set of elements, and you can see the original sets S and T remain unchanged. So it is a new set. Actually, it's a flat kind of copy of the elements. So we copy all the elements, but we don't copy the elements itself. We just copy the reference to the elements and put them into a new set. And this is a result of the function. So you see both elements 2 and 3 are contained in both sets, like S and T. And this is how you can intersect two sets. And actually, there's more to it, to the set intersection. So for example, you can do the following. You can intersect multiple sets. So for example, we can pass intersection, say we pass 3 sets. The first set has 1 element. The second set has, say, 1, 2, 4, 5, has 4 elements, and the last one has, say, 9, 10, 11, 3 elements. So even sets that are like they don't contain any elements, of course you can pass them into the set intersection method. And then, like, what would be the output of this method? What would be the return value? You can think about this. Pause the video for a moment if you need to. So we are trying to intersect this set with 3 elements, 1 to 3, with these sets. So basically in this case, we are looking for elements that are in all sets you pass into the set intersection method. And of course, I mean, as we have like this set 9, 10, 11, those 3 elements are not members of this original set S. So in this case, of course, we don't have any element that actually is a member of all sets that are affected. So the return value would be the empty set. Okay, but so for example, let's have another example and remove this last. Sorry about that. And so now we remove this, and we still have multiple set elements as sets as arguments to the intersection function method, and the element that appears in all sets, including the original set S, is 1, right? Because I mean we only have one set with an element 1, so if there can be a candidate, it must be this one. And you can already see the set intersection. So the return value of the intersection function is a new set, and this new set can contain only, at maximum, as many elements as the smallest set, right? So think about this. I mean the elements have to appear in each set that is passed as an argument, or that is used, that is called where you call the function upon. So the minimum set determines the maximum number of elements. So we need to we don't need to consider. So even if we have a set with 10,000 elements, but one set in the argument list has only 2 elements, then we need to perform at most 2 operations, right? So the runtime complexity is proportional to the smallest set that is used in the intersection method. So in this case, 1. So let's have an example. Like, let's check out the runtime complexity of this operation. So I've prepared some code. I will show you in a moment. So here we have we again import matplotlib and the time library. We create sets of different sizes from 100,000 elements to 5 million elements. We track the runtimes in a list. Then we iterate over all set sizes and create 2 sets, S and T. And they partially overlap. So we intersect them here, and we simply track the time starting and stopping before and after the intersection method is called. So then like by appending the runtime, this gives us the time.time function gives us the current system time in seconds. So we basically get the runtime in seconds when calculating the difference between both timestamps. So we append this timestamp, the difference, so the elapsed runtime for the set.intersection method into our runtimes, and then show the whole plot. So let's run this. It takes a bit, but it should be done rather quickly. I run this on my computer with like 8 GB of memory, Intel Core i7. So it's like not the newest computer. It would be probably faster in your case if you would repeat this the same code, but at least if you have a newer hardware than I have. And you can see the runtime is approximately linear. Okay, so it doesn't take a lot of time. It takes like split second to intersect two sets with like even millions of elements. But I mean, over time, of course, I mean, it accumulates. And you see the runtime on the y-axis increases with increasing set size on the x-axis. So we have like this almost linear relationship. And of course, it will be like not perfectly linear, because on your computer, nothing is perfect. There's a lot of variance in runtime just because you're working on a computer. Other processes run in the background on the computer, so it will be like a bit spiky. But in any case, you see the overall trend is like linear in the relationship between the set size and the runtime is linear. So so this is one thing I want to show you, but then I also want to show you like one other thing, an alternative way of writing the intersection. And this is actually very important because you see it many instances. Is so I first show you again the original way. So we have like this lengthy intersection method would intersect two sets, for example this 1 2 3 with 2 3 4, and the result would be 2 3, right? But then an alternative way that is much more concise and more readable in my opinion is to use the AND operator. And this operator is called it's an overloaded operator. And overloaded means because in other instances the AND has a different meaning, but in this case, like if you apply it to two sets, then it will basically calculate the intersection of both sets and create a new set with all the elements that are in the intersection of those sets. That basically the overlap between two sets. And you can also, like if you run this, you see it is exactly the same output. It is shorter, it is equally efficient, and I think more readable. We have less clutter like here with function calls and opening brackets and so on. We just intersect two sets straight away. So this is basically has the same runtime behavior. Everything is the same. It's just different syntax of doing the same thing. So and I would prefer using actually the AND symbol when intersecting two sets than over the intersection method. So they are semantically identical ways of intersecting two sets. Then there's also another function called intersection update. And so what does this do? So let's have an example for intersection update. So say we have the original set 1 2 3, and then we call intersection underscore update on this set, and we basically as input we intersected with say the same set 2 3 4. Now in this case, so in all other cases you have seen, we simply create, so if you call s.intersection, we create a new set. So the return value of the intersection method is a new set with the elements in the overlap. But if you call intersection update, it doesn't return anything. So you see it doesn't have any return value. Basically it returns none, but my interpreter doesn't show none as a return value. It simply shows no return value, so it doesn't even give me the none return value. Instead, it has side effects. The method intersection update has side effect. It changes the original set on which you call it. So in this case, it changes the set S. So if we now look at the set S, you see the set S has changed. So it basically performs the same operation. It calculates the intersection, but then it stores the intersection in the set on which you call it, rather than returning a new set. And this is like the difference between the intersection method and the intersection update method. So one creates a new set and returns a new set. The other one works on an existing set and doesn't return anything. Because it works on the existing set, it has side effects. It doesn't need to return anything. So I think these are the most important pieces of knowledge you need to understand. So we have discussed multiple arguments. We have discussed the intersection update function and the difference between the intersection method. We have discussed the runtime complexity. We have discussed the alternative way of intersecting sets with the AND operator. And we have looked at some basic examples of set intersection. So I think you have now learned the most important pieces of knowledge you need to understand about the Python set intersection method. So thanks for watching this video and see you in the next video. Bye.